Hello guys, welcome to my channel. So this is Cisco Catalyst SD-WAN component day 3. So now we are going to discuss about Cisco SD-WAN components, right? So let's move on to this screen. So this is SD-WAN component, and you can see this screen. I have drawn all the components here. So almost all the components. So this is the CS server. This is the validator, manager, and controller. And this is the CH routers, right? So in Cisco SD-WAN, we can see the SD-WAN distributes the routers or existing WAN routers between two separate plane, right? So in traditional way, if we can try to draw a traditional router, right? So this is the SD-WAN router. This is the traditional router, right? So in traditional router, we can we have this is the control plane, and this is switch fabric, and now it's data. We have another plane which is management plane, but uh, most of the routers don't have separate management plane, right? So the control plane is also used for management plane, right? So let's discuss about the control plane and switch fabric and data plane, right? So in traditional router, we have these two planes, right? So whenever we configure any route in router, so control plane basically is a CPU, right? Central Processing Unit. So it's a software, right? And data plane is hardware. Means we have ASIC, application specific integrated IC, integrated circuit, right? So this is the ASIC, and all ports are belongs to this data plane, right? All ports of uh, routers, all ports are belong to this data plane, right? So now whenever we configure any route, whatever it is, it's a static route or dynamic route, OSPF, PIGRP, whatever it is, whenever we can configure a route in router, what control plane is then control plane is just download this route to this data plane. So we have another term in control plane, which is RIB, right? Routing information base. So routing information base and FIB, right? So forwarding information base. So FIB in data plane and RIB in control plane, right? Whenever we configure any route, it just download this route to this forwarding information base, right? So how this download from this switch fabric, right? So in data plane to control plane, or in uh, our interface card to CPU, we have dedicated connection, right? So in traditional router on box, we have control plane and management plane and data plane. So the router don't have to authenticate this data plane to control plane, right? So CPU don't have to authenticate separately to this data plane, whether this data plane is belong to this control plane or not, right? But in SD-WAN, all SD-WAN vendors, what they did, they just separate their control plane and data plane, right? So in Cisco SD-WAN, we have separate control plane, right? And we have separate data plane. So all edge routers belongs to data plane, right? And all controllers belongs to control plane, right? So in control plane, we have separate controllers, right? So for what I just talking right now, this is the control plane and data plane. So there is no need to control plane and data plane authenticate each other because they belongs to the same box, right? And they are directly connected with this control plane and data plane, right? But in Cisco SD-WAN, we have a separate control plane, right? So, let's say this control plane or these controllers sits are in data center, and these sites belongs in separate districts, right? Or separate states. So if this data plane try to connect this control plane, so what it has to travel through this ISP and then it's connect to this controller, right? So the control plane and data planes are separated location wise, right? So that's why we have some mechanism in SD-WAN. Whenever a router wants to communicate with control plane, first of all, this router has to this router has to validate or authenticate himself to this validator. So the validator is a controller, and this validator is a first point of authentication of this SD-WAN fabric, right? So whenever a router wants to communicate with a controller or control plane, first this router has to authenticate himself to this validator, right? So not only this edge router authenticate himself to this validator, but also this router authenticate this validator, right? Whether this validator is belong to this organization or not, right? So this validator will be validated by this CH router as well. So this architecture known as JTN, Zero Trust Network Architecture. Okay, Zero Trust Network Architecture or whitelisting architecture, right? So both all the components belongs to this SD-WAN fabrics. They all authenticate each other. Means mutual authentication will be done between them, right? So the components which calls validator earlier is known as VWAN, right? But after Cisco acquired this SD-WAN technology from Vectila Systems, so it's rebrand as Cisco Catalyst SD-WAN, and all the controllers has also rebrand this VWAN. Earlier, this name was VWAN, and now it's known as Validator. And this manager, earlier this known was vManage, and now it's known as the manager. And the controller, earlier it was known as vSmart, and now it's rebrand as controller, right? So what validator did? So validator just validator validate the CH or edge routers. So first point of authentications, right? So the controller, we are talking about this validator, right? So validator is a validate first point of authentications, and it also what it do, it shares when a CH router wants to communicate with these controllers. So CH routers will come to this validator, and validators will validate this CH routers with serial number and their certificate, right? And as well as the organization name, by organization name, right? So when validator is validate the CH routers, after validating the CH routers, the validators will provide the manager and controllers IP to this CH router to communicate further. And the communication between CH router and validator is transient connection, right? So for the time being, this connection will build, and after few times, when the validation is completed and the manager's IP or controller's IP has been shared, these connections will be terminated, right? So the CH router, what it will do, it will communicate this manager as well as this controller for further process, right? So the two activities, validator first is authenticate this CH routers, and then it's provide this manager IPs, right? As well as the validator work as a Stone server, right? What mean by a Stone server? So Stone servers, whenever, let's suppose this CH routers behind the net, right? So we have a firewall, right? And behind the firewalls, we have CH routers, right? So CH routers is behind the net. So how come this validator knows this IP, right, of this CH router's IP, right? So it will come to this uh, netted device, right? But the validator will know behind the net IP, and it will also inform these CH routers that you are behind the net and your netted IP is 1.1.1.1, whatever the netted IP will be, right? And as well as this validator will inform this controller as well, right? It will inform the CH routers private IP as well as netted IP, right? So that this manager and controller will communicate with CH routers and push these all policies, right? So the validator will also work as a Stone server. And next thing is, and one more thing, this validator will form the DTLS connection with these controllers. So the V manager and V want DTLS communication or control communication will be 4, because V manage will use 4 CPU, and controller and validator, the control connection will be 2, because controllers will use 2 CPUs. But if you increase the CPUs, the control connections will be increased, right? Now come to this manager, right? So manager is a management plane, right? So we we have a management plane in the traditional router. So the traditional, the SD-WAN technology is also separate this management plane, right? So from this management plane, you will do all of the steps, right? Whether it's the routing configurations or policy configurations or QAS configurations, whatever we configure in SD-WAN, which will be done by this manager, and you will get the graphical user interface on manager, right? So you will get the GUI, graphical user interface, on this manager, right? So this manager is a management plane of this SD-WAN. You will get GUI, you can configure policy template, right? And you will monitor all this device. It will monitor all this device, as well as we can upgrade the iOS from this manager. So what you will do, the you will just authenticate these CH routers, and then you have to communicate this manager, right? So the managers and the routers will be know each other, right? So we will add this CH routers to this uh, manager. So the manager and router will reach each other, and from this manager we will push all the we will configure, and we will push the configuration to this controller, and the controller will push this configuration to this router. So there are two types of policies, which is a centralized control policy and data policy and local policies, right? So we will discuss later in details how the manager will work and how these policies and the configurations will be done through this GUI manager, right? And the sorry, so this will form the communication to this router, right? To this controllers, the controllers will form a tunnel, which is DTLS tunnel, right? And in DTLS tunnel, under this DTLS tunnel, the V manager will run SNMP for SNMP trap, ICMP for reachability check, and netconf for network configurations, right? So now let's come to the next controller, which is earlier known as DSmart, right? So this is the brain of SD-WAN. This is the heart of SD-WAN, right? So all types of routing, all types of policy, all types of we have template, we will push to this controller, and this controller will communicate this router and execute this routing informations, or execute this template as well, right? So the controller is a main control plane, right? This is the main control plane of this SD-WAN. So let's say this user, right? This is the site one, right? This site one. So if a user which is belong to site one is want to communicate with user which belong to site 10, so these decisions, these routing decisions will not be taken by these routers, right? Because this router has no capability to determine which traffic will go via which path, right? So all the routing decisions will be taken by this controller. So all the routing informations, all the policy push, all communications will be done by this controller, and it will it will establish the control connections between these routers, and the control connections will be a DTLS connection, right? DTLS connections, and under this DTLS connection, this controller will run OMP protocol. OMP protocol, overlay management protocol, right? So overlay management protocol is a routing protocol of this SD-WAN fabric, right? So this overlay management protocol will handle all the traffic, how traffic will go. So via this overlay management protocol, this CH routers. So suppose this is the CH router, and you have a local area network, right? So you have subnets, right? One subnet, right? And you are using OSPF, right? Between this edge router and your switch. So what you will do, you will just redistribute this connected route or static route or OSPF route to this OMP, which is running between CH router and controllers, right? And this router also will share all the information to this controller via OMP. We will redistribute this to this OMP, and all edge informations will come to this controller. So these edge routers will send the information to this controller, and this controller will send to this router as well as to this router, right? So it will work as a BGP route reflector, right? So whenever the all informations will come to these routers, they will form a overlay tunnel, which will be IPsec, which will be IPsec tunnel, right? And this IPsec tunnel or overlay traffic will be managed by this controller, right? And which protocol will be responsible for this management? OMP, right? Overlay management protocol will be taken care of all this overlay fabric, right? And another component is CH router, right? So we already talked about the CH router and control plane and data plane separation, right? So this control plane, we don't say that router don't have control plane, right? But let's suppose, why I'm saying this, let's suppose you have a router which is non-SDWAN router, right? So you have to communicate with non-SDWAN routers. You have a very contractor or vendors, right? So you have to communicate with that router as well. So you have a non-SDWAN router and you have to run this. You have to run BGP on this router, right? So whenever you configure BGP, so your router should have the control plane to decide which route will be configured on this router, right? Which configurations will be done, right? So routing configuration will be done by this non-SDWAN routing, and you will configure the OSPF or BGP on this uh, non-SDWAN router, right? And you will configure IPsec, right? In traditional IPsec, right? But this in SD-WAN fabric, in SD-WAN fabric, this router will not take in any decision by themselves, right? So in SD-WAN fabric, all decisions will be taken by this controller. So these users should talk with these users or not. These users will talk, these users will not, right? All decisions will be taken care by this controller, not by this routers, right? So it will increase the performance because the routing decisions will be taken care by these controllers, not by on box, right? On distributed manner, right? So this is the CH router and DH router. So these routers will be physical or virtual, but these controllers must be virtual, right? So the controller will be deployed on-prem or public cloud like AWS, Azure, or GCP, right? Or Cisco hosted cloud, right? And these routers can be physical or can be virtual, right? And you don't have license for this controller, but you have to have license for this routers, right? Whether it is virtual router or physical router, you have to have a SDN license, right? So this is the SD-WAN components what I want to showcase you, right? Here is the architecture. What's the this the vManage, this vWAN, right? What I have discussed earlier, all are written in here, right? So this is the management plane, control plane, orchestrator plane, data plane, right? We all talked all of these things, right? So thank you for watching these videos, and please like, comment, and subscribe if you liking this series. And we will cover all the theory and lab as well. So thank you once again.